So welcome to the class on probability. So we are going to have our second discussion on probability. So in the first discussion what we saw? We saw the basic definition of probability. Probability of E, that is the chance that event E will occur, that is nothing but n of E by n of S. S is the sample space. What is sample space? It's a set contains all possible outcomes. All possible outcomes. And then E complement is the set. E complement is the set. What do you mean by E complement? E complement is the event E not occurring, correct? And probability of E plus probability of E complement will always be 1. We also use this in our problem in a way how to simplify the problem and solve using this technique. We use this, right? Because probability of E is now what? 1 minus probability of E complement. So if E complement can be computed in a easier way than probability of E, then we can find probability of E as 1 minus probability of E complement in a very fast way. And S is my sample space which contains the all possible outcomes. Okay. Then we saw principle of counting. In this we saw that what do you mean by NCR and NPR? This is nothing but from set of n, how many groups of R elements are possible. Correct? NPR is nothing but from a set of n, how many orderings of R elements are possible. Correct? And we learned how to use NCR and NPR for the construction of sample spaces. Correct? We also saw what do you mean by with replacement, without replacement, at least 5, all those things. We saw different models of problem. Clear? Okay. Now we will start the class with another problem. Okay. This problem was asked in GATE 2012. This was a GATE problem. Okay. Now the problem is like this. A fair coin is tossed till heads is obtained. Okay. What is the probability that odd number of trials are needed? Okay. What is the probability that odd number of trials are needed? What is the question saying? I have a coin, I keep on tossing it till I get heads. And now the question, I can get the heads in first time itself, or I can get first time head, tail, second time head, or it is possible that I get tail first 2 times and get head. Till I obtain head, I keep on tossing it. Or I get first 3 times tail and then 4th time head. Like that it keeps on going. So this is my set sample space. Okay. Now what is the probability, what is the set E? No. Okay. What is the set E? I want to get the heads in odd number of trials. That is, first I want to get head. I don't want it to get in the second trial because this is tail in the first time, head in the second time. Tail in the first time, tail in the second time, head in the third time. Correct? I want to get head on the odd number of trials. Correct? So it can be tail, head. It can be tail, head, like this. These are the favorable outcomes. Okay. Now directly let me write this in the probability. What is the probability that I will get head in the first time? What is probability of getting head? Probability of head is 1 by 2, because there are two outcomes, right? And probability of getting tail is also 1 by 2 for a coin, for a single toss of a coin. Now what this translates to? This will translate to, I get head in the first time, or I get head in the third trial. Correct? Not this, third trial, first, second, third, or I get head in the fifth trial, like this. That is, first time I get head, and second time, and first time I get head, this one, or always becomes plus. I have been saying this. Or I get tail in the first time, tail in the second time, head in the third time, or I get tail first, tail second, tail third, tail in the fourth, and head in the fifth, or like that it keeps on going. So this is nothing but 1 by 2 plus 1 by 2 the whole cube plus 1 by 2 the whole power 5 plus, till keep on going dot 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 dot. So this is nothing but, if I take 1 by 2 common outside, it will be 1 plus, I have taken 1 by 2 common outside, 1 by 2 the whole square plus 1 by 2 the whole power 4 plus dot 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 dot. This is nothing but what? 1 by 2 into 1 plus, what is 1 by 2 square? 1 by 2 square is nothing but 1 by 4. 1 by 2 power, the whole power 4 can be written as 1 by 4 the whole square plus dot 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 dot. We will continue it. PTO. We will continue it. So what we got? This is not, we got a probability of E is nothing but 1 by 1 plus 1 by 4 plus 1 by 4 the whole square. Correct? Plus so on. So what is this? What is 1 plus 1 by 4 plus 1 by 4 the whole square? What it is? This is nothing but 1 minus 1 by 4 power minus 1. Correct? And there is a outside, there is 1 by 2 sitting. Correct? Yes or no? Outside there is 1 by 2 sitting, which we took as common. Correct? So 1 by 2 will be sitting here also. So this is nothing but, see how I got this? Because this is nothing but 1 plus x square plus so on. And this series is nothing but 1 minus x power minus 1 if mod x is less than 1. Correct? If mod x is greater than 1, we cannot apply this. This is a very important criteria. Mod x should be less than 1. Then only I can apply this, or else I cannot apply it. Okay, please remember. So don't simply apply this as 1 minus x power minus 1. This series will converge to 1 minus x power minus 1 only when this is the x, right? This has to be less than 1. Else this cannot be applied. So this is nothing but 1 by 2. Here 1 by 4 is less than 1. So I am allowed to apply that rule. 1 by 2 into 3 by 4 inverse. This is nothing but 1 by 2 into 4 by 3. This cancels to give me 2 by 3. This is the solution. Okay. Now let us solve the same problem in the other way. What is the asked in the question? This is the solution. We have already got the solution. Let us verify that our solution. What is probability of E? For the given problem, obtain head on even on odd trial. Correct? This is what it is. So what will be probability of E complement? Obtaining head on even trial. Correct? It's not obtaining tail on odd trial. Okay, please don't make mistake like that. It is obtaining head on the even trial. That is what is the probability of the event. E complement. So probability of E is nothing but 1 minus probability of E complement. What is E complement? Obtaining tail on the even trial. Head on the even trial. E complement will look something like this. First time I get a tail, I obtain the first head on the even trial, or I obtain the head on the even trial, that is fourth trial, or I obtain the head on the sixth trial, like this. I am getting always heads on the even trials. Like this it keeps on going infinite times till I keep on doing it. So it's a infinite series. So it will be 1 minus I get head on the second trial. That will be first time I get a tail, second time I get a head, or I get head on the fourth trial. First two are tails, I get the head on the first three are tails, I get head on the fourth trial, or first 5 times I get tails and on the sixth trial I get the head, and it keeps on going. So what we will get? 1 minus 1 by 4 plus what? This if I treat it as 1 by 2, I will like to treat it as 1 by 2 into 1 by 2, I will treat it as 1 by 4. So what I will get? This is nothing but 1 by 4 plus 1 by 4 the whole square plus 1 by 4 the whole cube, like this. See, now you can ask me why you are grouping 2 1 by 2 as 1 by 4. It is just because I know what is the meaning of this series. 1 plus x square plus x cube plus so on is nothing but 1 minus x power minus 1 if mod x is less than 1. I know the expansion of this series, correct, but I don't know the expansion of this series. See, suppose if I retain the 1 by 2 as such, I will get a series something like 1 plus x square plus x power 4 plus x power 6 plus x power 8 plus something. We don't know the simplification of this series. I know the simplification of this series. So only I am grouping two 1 by 2s to form 1 by 4 so that I convert it into this form. Thereby I can bring it to this structure. Clear? It's just a way of simplifying. Okay. So what is this? This is nothing but what it will give me. Now I can take 1 by 4 common outside. If I take 1 by 4 common outside, what will I get? 1 plus 1 by 4 plus 1 by 4 square plus so on. So this is nothing but 1 minus 1 by 4 into, this is 1 minus 1 by 4 inverse, correct? Because this is of this form. So this is nothing but 1 minus 1 by 4 into 4 by 3 is what we will get. So 1 minus 1 by 3. 1 by 3 is the probability of E complement actually. So 1 minus probability of E complement will give me probability of E. This is what we got here, correct? This is what we got as solution here, right? So we have verified our solution. This is verified to be correct. This is correct. Clear? Fine. Okay. Now I have modified the same problem what was asked in GATE into a little bit different problem. A biased coin is tossed. In the previous problem it was a fair coin. Fair coin means what? What do you mean by a fair coin? Fair coin means probability of head is also 1 by 2. Probability of tail is also 1 by 2. Whenever something is said as fair, that means it is called equally likely chances. Equally likely chances. Correct? Head is also equally favored, tail is also equally favored. But now the coin is now biased. That is, I am doing something to the coin such that it will show head more number of times or tail more number of times than head. That depends upon how we have biased the coins. So moment I am saying biased coin, what you should say is probability of head or is not 1 by 2. Please remember this. Yeah, biased, and this has to be told. How I am biasing it, God knows. This information has to be given in the problem. If this information is not given, nobody can solve this problem. See, I can bias the coin such that to give a tail 1 by 4 times, every one out of 4 tosses it should give me 1 head, or out of 100 tosses it should give me 1 head, or out of 1 crore tosses it should give me 1 head. That depends upon how I am biasing the coin. Correct? So this how I am biasing the coin has to be told in the problem, else it is impossible to solve. But remember, it will not be 1 by 2. So a biased coin is tossed till heads is obtained. What is the probability that odd trials are needed? This we have already seen it, correct? This we have already seen it. That is what was asked in GATE 2012 for a fair coin. This we already solved it. Now this is the extra information given to you. Probability of head is 1 by 3. Probability of tails is 2 by 3 for a single toss. That is, you see here, this is not 1 by 2. I have biased the coin to favor tail more than head. This is what is called biased. Clear? So now what is the event? I want heads in the odd trial. That is, it can be head or it can be tail head, or it can be tail 4 times, 5th time I get head, or I get tails on first 6 times, then I get head. These are all what I consider to be favorable. That is, I get head on the 1st, 3rd, 5th, 7th, like that. On the odd trials I am getting the head. So what is the probability of E? It is nothing but probability of getting the head on the first trial. That is 1 by 3, or I get the head on the 3rd trial. First 2 times I get tails, 3rd time I get head, or 5th time I get, first 4 times I get tails, 5th time I get a head. Like that it keeps on going. Correct? Now clearly you can see 1 by 3 present everywhere. Okay, let me pull that 1 by 3 outside. So 1 by 3 into 1 plus 2 by 3 into 2 by 3 plus 2 by 3 into 2 by 3 into 2 by 3 into 2 by 3, like that it keeps on going. Correct? So this will be nothing but 1 by 3 into 1 plus, I can see if I treat it like, if I treat 2 by 3 as x, I will get 1 plus x square plus x power 4. I don't know what is that series. Whereas if I group these 2 by 3's together, I will get it as 4 by 9 plus this 2 4 by 9 square. Like that it goes. I know the expansion of this series. What? 1 plus x square plus so on is nothing but 1 minus x power minus 1 if mod x is less than 1. So now this is in this form. Correct? So we will get probability of E is nothing but 1 by 3 into 1 minus 4 by 9 inverse, that is nothing but 1 by 3 into 5 by 9 inverse, that is nothing but 1 by 3 into 9 by 5. This is nothing but 3 by 5. So this is what is the probability. Now observe, what all points I want you to observe is the following. How I biased the coin? I biased to favor tails than heads. Correct? So now the probability of getting a head will reduce. So the probability of getting a head on the odd trial will also reduce. What was the answer without biasing what we got? Without biasing what we got as answer, we solved it, right? This came as a GATE 2012 problem. We solved it, right? The answer was 2 by 3. Now with biasing we are getting it to be 3 by 5. Because I biased to favor tails, so the probability is dropping down. That is 3 by 5 is less than 2 by 3. Correct? 3 by 5 is 60% chance, whereas this is 66.67% chance, right? Because I biased to favor the tails more, the probability of getting a head is going down. Please observe this. These are really interesting points to observe. Okay? Fine. Okay. This is another interesting one. Probability that one tire will be healthy for a journey of 3000 miles is 90%. What is the probability that a car having 4 such tires is completing the journey of 3000 miles without any tire failure? Without any tire failure. Clear? That means what? No tire should fail. Means all 4 tires must be healthy. That is, if I call the tires as T1, T2, T3, T4, T1 must be healthy and T2 must be healthy and T3 must be healthy and T4 must be healthy. Okay. So when I say T1 and T2, that means what? Whenever I say and, in probability terms it translates into multiplication. Probability that T1 is healthy is what? 0.9. Probability that T2 is healthy is what? 0.9, because 90% is the probability that one tire will survive for 3000 miles. Correct? 90% is the chance that one tire will be healthy for a journey of 3000 miles. So we have 4 such tires. So the probability will be 0.9 power 4. So it will be how much? 0.9 power 4. It is 0.6561. That is nothing but 65.61% chance. See, this is what is the probability problem with a probability. One tire has a healthy chance of 90%, but when I have 4 such tires, 90% appears to be a very big number, but when I have 4 such elements, that is 4 such tires, and probability that all of them will be healthy will become just 65%. See the reduction. Okay. See the reduction in the chances. Okay. Fine. We will take one more problem. We will solve one more problem. Might be I am numbering it wrongly, I don't know. We will solve problems. As long as we are solving problems, count is not the important thing. Okay. This is the question. 3% of envelopes are defective in a pack of 100 envelopes. If 4 envelopes are drawn in random one by one without replacement, each and every word given in the problem is important. What is the probability that all 4 are non-defective envelopes? This is what is asked. Okay, that is, I have a pack containing 100 envelopes, out of which 3% are defective. That is what? Out of 100, let me write it here. This is the solution. Out of 100, 3% are defective. That is how much? Implies 3 envelopes are defective. 3 envelopes are defective. Now, I am going to draw 4 envelopes one by one without replacement. That is, first time I am drawing 1 from the 100. Correct? First time I am drawing 1 from the 100. Second time I am not going to replace, so I will get to draw 1 from the 99. Third time I get to draw 1 from the 98. Fourth time I get to draw one from the 97. Correct? Yes or no? I can pick any one among the 100. Now any one among the 99 in the second chance, any one among the 98 in the third chance, any one among the 97 in the fourth chance. Correct? This is what is my sample space. My event space will be what? My event will be what? I consider what is the event? I want all the 4 to be non-defective. That is, how many non-defectives are there? If 3 envelopes are defective, 97 non-defective envelopes are present. Correct? Because total is 100 envelopes. So first time I should pick anything among the 97. Second time, if I have picked one among this 97 I have picked one envelope. If that envelope is the healthy envelope, this count will reduce. Correct? So second time I have to pick one from this remaining 96. Third time I have to pick one among this 95. Fourth time I have to pick one among this 94. This is what is my event. First one is the sample space. Second one is the event. Correct? Are you understanding this? Let me repeat. There are totally 100 envelopes. So I can pick any one without replacement. So when I pick one from the 100, the second time I get a chance to pick one from the 99. Third time I get a chance to pick one from the 98. Fourth time I get a chance to pick from the 97. But I consider my event to be successful only when all the 4 are non-defective. Correct? That is what is asked. What is the probability that all 4 are non-defective if I draw one by one without replacement? So first time I have to pick a non-defective envelope. Totally 97 non-defectives are there. So I am picking one among, I am assuming that I am picking one among the 97. So if I picked that one envelope among the 97, the number of non-defective envelopes will go down. So it becomes 96. For the third trial it will become 95. For the fourth trial it will become 94. Clear? Fine. Means what? I am writing this again. What is my E? First time I get to pick one among 97. Second time I get to pick one among 96. Third time I get to pick one among 95. Fourth time I get to pick one among 94. What is my sample space? Initially there are 100 envelopes. So first time I get to pick among 100. Second time 99. Third time 98. Correct? Fourth time I get to pick among 97. Correct? So I have to pick one. So what will be my sample space? Probability of E will be what? Now N of E divided by N of S. Correct? So first time I have to pick one among 100. And second time I have to pick one among 99. Third time I have to pick one among 98. Fourth time I have to pick one among 97. That is my sample space. Event is nothing but 97 C1 into 96 C1 into 95 C1 into 94 C1. So if I multiply this, 97 C1 is nothing but 97 itself. 96 C1 is nothing but 96 itself. So it's nothing but how much? 97 into 96 into 95 into 94 divided by 100 into 99 into 98 into 97. It becomes 0.8836. That is 88.36% chance that all 4 are non-defective. Okay? Now let us solve the same thing. Let us solve the same problem assuming replacement. We solved without replacement, right? Now assuming envelopes are replaced. Envelopes are replaced after every draw. That is, first time I draw one envelope, see that it is non defective and keep it back. Second time I can pick anything. So here what will happen? First time your sample space will be, first time also you get to pick 1 among 100, second time also you will get to pick 1 among 100, third time also you will get to pick 1 among 100, fourth time also you will get to pick 1 among 100. Whereas your event will be what? First time also you will get to pick 1 among the 97 non-defective envelope, second time also 97, 97, 97. Because why this is? Because envelopes are replaced. That is, I take 100 envelopes are there, from that I take one envelope, see what it is and keep it back. Again I draw one, keep it back, like that. So what will be probability of E? Probability of E is nothing but 97 C1 into 97 C1 into 97 C1 into 97 C1 divided by 100 C1 into 100 C1 into 100 C1 into 100 C1 becomes 97 power 4 by 100 power 4. What is this? What will be this? 97 power 4 divided by 100 power 4. So it is 88.52%. 88.52% or 0.8852. Observe, when we are when we draw and keep it with ourselves, the number of non-defectives keeps on increasing. The ratio of non-defective to defective is more now when we don't replace. So when we don't replace, the probability that all 4 are defective is 88.36 only. Whereas when we are replacing, it is 88.52. So the probability is increasing. Always remember, with replacement probability will be increasing than without replacement. Clear? With replacement probability will be always more than without replacement probability. Okay, this is again one more type. A lot contains 8 items of which 3 are defective. Okay. A lot contains 8 items of which 3 are defective. Now, if 3 items are sampled, what is the probability? If 3 items are sampled, what is the probability that there will be more than one defective item? More than one defective item. Okay. The question is, okay, there are totally 8 items. Okay. Let me say that there are totally 8 items are there, right? Out of which 3 are defective. Okay, let me use the red color for that one. Defective, defective, defective. Remaining all are healthy. Remaining all are fine. Now, the question is, if 3 items are sampled, okay, it's a random sampling, okay. What is the probability that there will be more than one defective item? That is, totally 8 items are there. From this you are going to pick a sample of 3. So sample space is what? Sample space will be how many groups of 3 can be formed from given group of 8. So that is n of s will be 8C3. Okay. Now the question is, what is the probability that there will be more than one defective item? More than one defective item means what? Defective more than one means what? There can be 2 defects or there can be 3 defects. But I am going to draw 3 items, correct? So there can be 2 defective and 1 healthy and 2 defective. 1 healthy and 2 defective, or 3 defective and 0 healthy component. Correct? So means what? How many healthy components are there? How many healthy components are there? 1, 2, 3, 4, 5. Correct? 1, 2, 3, 4, 5. 5 healthy components are there. Defective, how many are there? 3. So I have to select more than one defective, means there can be 2 defective or 3 defective. Why 2 defective, 3 defective? Because I am going to sample 3 items. Correct? When I am sampling 3 items and I am saying that more than one should be defective, means either 2 can be defective and one will be healthy, or all the 3 are defective. That's what is more than one defective means. So or translates into plus and will always translate into multiplication. Remember this. So I have to pick one healthy from the 5. So 5C1. 2 defective means what? 2 defective means from the 3 I need to pick 2, or all the 3 I pick from the defective and I pick nothing from the healthy. So this becomes 5C1 into 3C2 plus 3C3, because 5C0 is 1. So what this will become? This is what is my N of E. N of E will become how much? 5C1 is 5 itself. 3C2 is same as 3C1 because NCR is same as NCN minus R. So 3C2 will be same as 3C1. So it is 5 into 3 plus 3C3 is same as what? 3C3 will be same as 3C0. So it is 1. Correct? So it will be 5 into 3 plus 1. This will be 16. And 8C3 will be how much? 8C3 will be 56. Okay. So probability of E will be N of E divided by N of S. This is nothing but 16 divided by 56. That is 0.2857. Clear? I think we have solved sufficient number of problems in this area. We will move towards other area called conditional probability now. We have finished this, so we will be moving towards conditional probability. Okay, what do you mean by conditional probability is what is the question. For understanding conditional probability, we should understand what do you mean by conditional probability first of all. So what is exactly conditional probability? Means it's written something like this. This is nothing but it's written. I will explain you each and every meaning of each and everything I am writing. Probability of B intersection A divided by probability of A. See, actually what happens? Okay, let us talk. What do you mean by probability of A? What do you mean by probability of B? Nothing but N of B. B is a event. Okay, take B. A and B are events. Okay. Now probability of B is nothing but N of B divided by N of S. So if I draw it in terms of Venn diagram, this is A, this is B, this is S. Okay. So probability of B is nothing but the one what I am trying to shade in the violet color now. This is what is probability of B. N of B divided by N of S. So this shaded region represents the probability of B. Correct? Now suppose I say that event A has occurred for sure. Event A has occurred for sure. Now I am asking you to find how much is the chance that probable event B will occur. This is called conditional probability. Now what happens the moment I say event A has occurred, the chance that event B can occur is only this much. What I am shading by now, the pink color. This is the portion of which is common to A and B. Correct? So, the thing is now event A has occurred. So, the moment I say event A has occurred, probability of B such that event A has occurred, that's what it means, is nothing but this divided by the probability of, because now A becomes the sample space. Because whatever is known for sure will be the sample space. Sample space is certainty. Please remember that. Anyway, I will explain you this. This is nothing but now n of B intersection A divided by n of A. This is nothing but, if I multiply and divide by probability by S, what will I get? N of B intersection A divided by n of S into, I am multiplying and dividing by n of S, into n of S divided by n of A. This is nothing but probability of B intersection A divided by probability of A. I will explain the meaning now. We have derived this, we will see what is the meaning of this now. Okay. Now what do you mean by sample space? Sample space is certainty, or I can say sure to happen. When it is sure to happen, no probability exists. There is no probability. That is, probability is 1. When I say probability is 1, it is certainly going to happen or sure to happen. That is what you mean by sample space. That is, if I throw a dice, I will get 1, 2, 3, 4, 5, 6. These are all the possible outcomes. Now, if I throw the dice and say that, what is the probability that I will get any number between 1 and 6? The probability will be probability of getting any number between 1 to 6 in throw of a dice. What will be this? This will be 1. Correct? Yes or no? Because sample space is definitely going to happen, because sample space contains all possible outcomes. Correct? Now, let us discuss the same thing in a different perspective. This is A. This is B. Okay. Now, this region is A intersection B. Let A and B be two events. Now, I am saying with guarantee that event A has happened. Event A has happened. The moment you say event A has happened means it is certainty. The moment you say it with certainty, there is no probability associated. Event A has happened means, see, for example, if you say that cricket match is going on, till the match is getting completed, you cannot say which team won. You can say only probability that India will win is so much, probability that Australia will win is so much. But moment the match is over, there is no probability. After the match, India won. It is a certain statement. Or Australia won. It is a certain statement. Correct? So now I am saying event A has occurred. That means this A, something from here has occurred. Something from A has occurred. This has occurred. Now I am asking you, what is the probability that event B can occur, or B could have occurred. What is the probability? This is now what? This area. This is what, or rather than I am saying area, this is the favorable outcome. This region will be the favorable outcomes, and this region will be the sample space now, because this has only occurred. Rest everything is meaningless for me. That is nothing but n of A intersection B. Probability that B occurs having A occurred. A has occurred. So what is the probability that B will occur? Probability that B will occur okay if A has occurred. That is what this statement means. That's what is this P of B bar A means. Okay, this is nothing but what? This is nothing but n of A intersection B divided by n of A. If I multiply and divide by n of S, what will I get? N of A intersection B divided by n of S into n of S divided by n of A. And n of A intersection B by n of S is nothing but probability of A intersection B, and n of S by n of A is nothing but 1 by probability of A. So therefore probability that B occurs having A has occurred is nothing but probability of A intersection B divided by probability of A. Clear? This is what is the answer. And this is what is called conditional probability. We will see this with examples now. We will see this with examples in the next session.